This is an introduction to mass spectroscopy. What I have here is a whiteboard. You have a top-down view of this whiteboard. You'll notice I have a ramp as well on the side here, and I have a tick mark, and that tick mark is to let me know where I can start the marbles from each time, so that way I'm doing it consistently every time. So let me go ahead and get started. Here is a glass marble. So notice nothing necessarily special about the glass marble. It's green, about it. And when I start it at the line, you'll notice that it moved straight across the whiteboard. Let me do that again. Okay. And what I'm going to do is mark the whiteboard with the straight line path so you can see which way it went. So it left the whiteboard about here. Let's double check. Yep. And so we have an approximate straight line path to the edge of the whiteboard. And granted, I understand that I didn't draw it perfectly straight, but you get the point. Yep. All right. So the next question. Here I have a steel ball bearing. It is the largest steel ball bearing that I've got. What I'm asking is, what is it going to do when I drop it off of this ramp? Make your guesses. So you'll notice that when I dropped it, it seemed to go off at the very edge of the whiteboard. Let me do that again. Yeah. So why did the path deviate? What made that thing turn in that direction? Why did it follow a straight line? All right, so with any luck, you've got your guess in so far. And what I have here is here's the large one that I just put onto the whiteboard a little while ago that went off in that corner. And I have a ball bearing that is slightly smaller. What I'd like you to do is make a guess. What do you think is going to happen when I drop the slightly smaller one off the ramp from the same spot? Here we go. All right, this one seemed to have come off the ramp, or come off the board at that edge. Let's do that again. Yeah. So why would the slightly smaller one change in its path? Well, why did the metal one move at all? Well, first let's go ahead and answer that question. On the bottom of this whiteboard, I have a neodymium magnet. So this magnet down here is what's causing the path of the marble to deviate. All right, so why would, now, could you guess, why does the large marble not deviate as much as the small one? And why does the large one not deviate as much as the small one? So the small one deviates more. All right, so now what I've got are a few more here, and they are in order of largest, the one that you've already seen, and then I've got these two, and you'll notice how close in size these two are to each other. So the question that I have at this point is, do you think that the magnet will have the ability to separate these distinguished on the whiteboard? In other words, will they fall at the same spot or will they fall at different spots because they're so close in size? All right, I'm going to take the larger of the two first. I think that came off about here. Same one, the larger of the two. Yeah, so it deviated here. Here's the smaller of the two. Wow, that deviated quite a lot. Let's do that one again. Okay. Again. Yeah, so it's hitting right about this section over here. All right, so you'll notice that the smaller the size of the marble, the smaller the mass of the marble, the more it deviates from the straight line path. All right, so now I still have yet another marble that is smaller yet. So here are the first four, and then this one down here at the end, you'll notice is even smaller. Let's see what happens with that one. Well, it got stuck to the magnet. Yep. All right, so some questions that you should be able to answer as well is, what do you think we could do to adjust this system if I needed to actually have these really small marbles fall off the side and actually go off the ledge over here? All right, so other major question. So here are these two that came off this edge, the ones that were really close in size to each other. Now let's say that, I'm not even worried about these anymore, but let's say that I have 100 of these, and I have, let's say, 50 of those. Okay, so I have 50 of the larger ones and 100 of the smaller ones. If I had just a big old bag full of these, they're really hard to tell the size, and chances are running them through a sieve wouldn't exactly work very well. But could I use this system to be able to separate a pile of these marbles? If I had 150 marbles all mixed together and 100 of them were the smaller ones and 50 of them were the larger ones, could I end up with two separate piles? The answer to that is yes, I would be able to separate these marbles from each other. What I would need, though, is to have a separate bucket on each side to be able to collect them, which would be fine. All right, so then if I had them and I started dropping these, you'll notice that it would separate off into separate piles. But let's say that I had a counter, that every single time that one of these fell off the edge, a counter would tick up larger and larger and larger over the side. Okay, so it would basically be making a graph of this spot here and this spot here. Okay? How would these two lines be different from each other if I had a counter for each time one of them fell off of the edge? All right, so for the one that would have 100 marbles, I would have twice as many, or a graph that would be 2 times taller than the 50 line. So this would then be at a 1:2 ratio. Okay. So what could we do with that information? Well, this entire idea is supposed to give you an idea of how mass spectroscopy is supposed to work. So let's say that we have chlorine 37 and chlorine 35. Oops. So if I have isotopes of chlorine 37 and chlorine 35, what would I need to do to be able to separate out chlorine 35 from chlorine 37? Well, the first thing that I would need to do is that if I have an atom of chlorine, atoms of chlorine are neutral, which means just like the glass marble when we started, if I have a glass marble and I drop it down the ramp, it's just going to go straight this direction. It's not going to deviate whatsoever. And that would happen with chlorine 37 or with chlorine 35. So you'll notice here I have a wooden marble. If I dropped a wooden marble down here, you'll notice it takes the same path as a glass marble. So if it's not affected by the magnet, it's not going to deviate. So what do we have to do to be able to make chlorine 35 and chlorine 37 able to deviate off of the path? Well, we'd have to figure out a way of making chlorine 37 and chlorine 35 charged. So turning a marble that's like this into a metal marble, that process would be called ionization. And in a mass spectroscopy machine, you would ionize all of the atoms, or as many of the atoms as you could, that you were going to run through the machine, so it would be affected by a magnet. So the first step, ionization. Second step is we have to accelerate it, so more or less using this ramp to start running it by the magnet. Okay? So step 1, ionization. Step 2, acceleration. Step 3 is deviation. In other words, the deviation is going to be that magnet that's underneath this board that's going to cause the paths to shift. And then last but not least is the detection. When it falls off the edge, we get a line or a counter that is making note of how many of each of these things are falling off of the side.